Joining baddies, welcome back to the videos problem number 16 of the 2023 AMC8. The letters P, Q, R are entered into a 20 by 20 table according to the pattern shown below. How many P's, Q's, and R's will appear in the completed table? So, first of all, there is obviously the obvious solution in which you just fill out an entire table, but that is extremely time consuming, so I prefer myself to go about a bit of kind of a table kind of thing, but not like the entire table. It's a new table. So basically what I'm saying is, if we look at this PQR, 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 RPQ, RPQ, QRP, whatever, so on, you guys can see that if we look at these columns, so these funny little things, they're classified into three types. Either a P column, which rotates in PQR, a Q column, which rotates in QRP, or an R column that rotates in RPQ. Then it just repeats. So as you guys can see here, we can basically calculate how many P columns, Q columns, and R columns there are, and then multiply each one by how many times they appear. And you might be like, oh, but aren't the PQR, PQRs all the same? And the number of P columns, the Q columns, R columns are all the same? And then your hand reaches for the answer choice, which have all the same numbers. However, that is actually not the case. If we look at this P column, first of all, let's say P, Q, R. It goes in a PQR order. Since 3 multiplied by 7 is equivalent to 21, that means that if we just did 7 for each of them, one of them is going to be sticking out the top of the column. Or in this case, the bottom, because I don't have the top of the column on screen. However, that means that that letter is not going to be counted into the total, and in this case, it just so happens to be the last letter, which is R, because that would be the 21st letter. Therefore, in the P and Q and R column, there are 7 P's, 7 Q's, but only 6 R's in a P column. So now let's look at our Q column, which is P column's neighbor. This is going in a QRP kind of rotation, and this is similar to our P column because the last letter is not going to be shown in the 21 kind of circumstance, and in this case it happens to be P. Therefore, in a Q column, there are 6 P's, 7 Q's, and 7 R's. Now let's look at our last column type, which is an R column. This R column has an RPQ kind of rotation, therefore we have 7 P's, only 6 Q's, and 7 R's. And you might be like, oh, well, I was right then, right? Well, there's only that many. They're all the same eventually, and they even out. However, that's not actually the case because we still need to look at how many there are. As you guys can see at the bottom of this row, this is a PQR rotation. Wowza. And in this PQR rotation, we already know how many times the P's, Q's, and R's happen. So this is also how many times a P column, a Q column, and an R column happen as well. Therefore, there are 7 P columns, 7 Q columns, but only 6 R columns. So now let's solve it. So 7 multiplied by 7 for our P columns, we have 49. 7 multiplied by 6, 42. 6 multiplied by 7, also 42. 7 multiplied by 7 is equivalent to 49. 7 multiplied by 7 again, also 49. 6 multiplied by 6, 36. 7 multiplied by 6, 42. 49, and 42. So as you guys can see, the P's are the same as the R's. However, the Q's, if you do a little bit of quick solving, you'll find that it's actually equivalent to one more than either the P's or the R's. Therefore, the correct answer is C, 133 P's, 134 Q's, and 133 R's. And as a side note, you don't even actually need to solve once you get to this phase, as you guys know that the P's and the R numbers are already the same. So you just need to scout the answer choices for one of those. And you also need to note that the Q number is also greater than the P number and the R number, or else you might get tripped up on D as well. So yeah, that's the end of this video. Hope you guys enjoyed, and I'll see you all on the next one. Bye bye!